Now, our first speaker is Vincente Botet, with 25 years of experience and 15 of that in C++. He's still looking for ways how to make better software and how to make C++ better, as he is actively contributing to Boost community and also files a proposal for new C++ standards. He was born in Spain. Today he came from France, where he works for Nokia. After hours, he likes to do gardening. That's probably why he sometimes speaks about software in aesthetic terms. When I ask him what he's looking for in the software, he said he's looking for beauty of it. So today, Vincent Botet will tell us how to make software beautiful with type classes, an alternative approach to customization points. Please welcome Vincente Botet.
The subject of the talk is about how we can customize some behavior on the standard library. It is missing a standard for C++20. And even if in the title we say an alternative, this technique is well known since a long time. It is just the presentation will explore what we can have using this technique on the standard. So what is the problem I have? It is that with the current or even proposed future way to customize, we cannot do that for concepts, and we cannot do that for types that are not deduced. We'll see in more detail. The second problem I see is that we have already some customization points in the standard, as swap, begin, end, C begin, C end, data, and we will have much more. And I believe that the way we are customizing this is in some way as if these words were pseudo keywords. And the third point is that the approach we use in the standard don't scale. We cannot use it for user-defined libraries. We cannot customize in the same way because the approach of the standard is to use overloading and ADL, and we cannot add overload on types of the standard. Then I will try to find a solution in order to solve these problems. We'll see what a customization point is, what will be the goals of a good design, what is the approach of C++17, what will be maybe the approach of C++20, and there is already an approach proposed for the range TS. And we will see some alternatives to this approach, and we'll finish by a conclusion. Then, the standard don't define what a customization point is, but in some papers we see that a customization point is a procedure, a function that the behavior will be supplied or refined by the user. In order to be able to, for the library to do a generic behavior, one sample example is short that needs swap. Okay. The proposal for the new way of customizing points in the standard, again, talk about function. a customization point is a function that is overloaded using ADL. How many of you know what ADL is beside the OK, thank you. I believe that a customization point is something more than a function. It is anything, any code that is provided by a user in order to make a generic algorithm. It's something that we are something more specific. Not only functions, it could be types, it could be constants, it could be something else. And I would say that when we have an interface, we have the client interface, the client side, and the customization side. And this should not be the same. It could, but there are two different interfaces, how to use and how to customize. And I would say that a customization point, it is not only about syntax, it is about semantics, and it is also about complexity, performance. We can have some additional constraints that we require. Let's see. I define a class that defines two operations, begin, end, and I use it like that. In a generic context, in a template, and this works for this class, but the interface, it is not generic enough, because I cannot use it for C arrays. Because C arrays, I cannot define members on a C array. Then I need to define a function that will be overloaded. And here, for example, we can define an overloaded begin function that just will forward to the member begin function when the member function is valid. And for that, we use return type deduction and spinaire. How many of you know about what spinaire is? OK, spinaire means substitution failure is not an error. That means that when we try to instantiate a template and there is an error, that means that the template, it is ignored. This instantiation is ignored. And we will find others that could be good matches. Then, having the possibility to overload for the begin member, we can now overload for std array. You imagine what this function should return. And now, I can use it in this way. I have defined two overloads, and I have access to them using std in a given context. OK. Sorry, apologize. There are a lot of typos, errors in the slides, and some additional slides between them, the preceding one. Then I will say what is a good design for customization point? I will say that a customization point should be always associated to a concept, to some global requirements, something that should have a name. When we talk about begin-end, we should think about begin-end on the range context. Otherwise, these words have no meaning. And the customization, I have said, should respect the concept constraints that could be not only syntactical. We say it should be easy to use, easy to customize correctly, and easy to call correctly, and very hard to use incorrectly. We don't want that someone customize our customization point by accident. And we don't want neither that a user call this customization point by accident. Anyway, we are in C++ and we want to be also as efficient as possible, and we don't want to add overhead with this design. And I would say that as we want to be able to customize something that a group of types that satisfies already a concept. We don't want to repeat ourselves, and we want to do that only once. And in the context of the standard, we cannot avoid to be backward compatible as much as possible, and any design should take care of this additional point. Okay, then in C++ 17, if I have a class that defines some kind of function begin that behaves as we could expect, then there is a mismatch, and we will not find this function. And we'll need to add a mapping between the dot begin in camel case and the dot begin that we are expecting, and the begin we are expecting. And this function will be defined by ADL, because this function is in the namespace associated to the class X. Then, if now we use it in this way with qualification of the std namespace, this means that we will not have access to ADL, because ADL it's used only when the function it is not qualified. Then this will not work as we expect. And if we don't qualify, well, this will work for X, but it will not work for the default definition we have in the standard. That means that we need to introduce the symbols, the function begin, std begin, and std end before calling to begin in an unqualified way, so that we have here, we have that begin is called, we have access to any overload associated by ADL, and as we have introduced std begin, we have also access to this function. This is what the range-based for loop does. It is something like that. It is not writing like that on the wording, but when we have this, it is as if we had this using std begin, std end. Like, this is not exactly. Because it is the compiler that do that. As you see, if we forgot to add this std, this using std, this is a little bit risky. We think that it is working, but it is not working for all the cases. Then what we want is to be a little bit more specific and that the library do that. We want that, for example, the library range will take care of adding these std functions and use ADL when the user has do the specialization. Okay, then we can start to see that the user interface here it's different to the customization one. I have used stdx here in order to say a standard, maybe the future standard or the std experimental, doesn't matter. And here we are trying to make the use easier because even it is we need to be very explicit. There is less risk, and this is what we want. We want that the functions are harder to use incorrectly. One drawback of using overload is that when we define an overload function using, for example, reference, the same overload will work also for derived classes. And sometimes this could be great, sometimes it is not what we would expect. I am not saying that it is something absolutely risky, but people need to consider that when they overload begin, we will have this overload for any class that derive from this class. Okay, let's see what the range says, and this slide was has as goals. The range says one that exactly that if we use it's not working. Yeah. If we use directly a customization point qualified, it works, of course. If we use it introducing the function, it works also. And they should behave identically. That means that whenever we use one of the other, if we have customized the customization point, it will be called. There is no shortcut. The second goal is that even when we are using this way, introducing std begin, we will not bypass the check of the constraints needed by this function. That means if std begin check that the result should be an iterator, this control should not be bypassed. We want to be able to control the constraints of the customization for all the functions of the concept. And two additional objectives for this from this proposal is C++, efficiency, no code bloat. Let's say how we do that with this proposal. In the experimental range proposal, we have the range namespace, but here range is not a concept. It is just a namespace to hold all the proposal associated to the range TS. First, what we do is we add the overload for the default customization points in a detailed namespace. for example, begin that forwards to a function that has dot begin, or begin for arrays. Then we define a function object that will just forward to the call of begin using ADL. And we take care that this is done only if the expression is well defined, as finite here. And now we define a variable of this function object. The details are not important. What we want is just that this function object exists only once on around all the compilation units. How does it work? It works because when we are using std_cust, cust is a function, it's a variable. And when we find in the first phase lookup a variable, we don't allow to, we don't look for the second phase lookup of overloading resolution. Then we find a variable of type, we take it. Then this ensures that when we do that, we are forcibly calling to the stdx begin. Okay? This is how overload resolution works. There are several phases, and the first phase stops when a variable or a function object instance is found. Well, we have introduced a function object, we have an instance, and we want to be as efficient as possible. And Eric Niebler, the guy that have made this proposal, you can find on the proposal exactly the code generated by at least the last compilers, and we have no overhead with this design. Okay? I believe that the trick that is used in order to ensure that there is no ODR, one definition rule, we don't violate the fact that the instance is exists only once, could be managed very well in C++17 with inline variables. But I have not had the opportunity to check it on a compiler. Okay. Here is the definition on the range.ts of what a customization point is. And I believe that this definition is really addressing the design that has been found. I believe that we should be have a definition that is larger, because this is a customization point that follow this design. I will let you read, but it is too much to add a specific design. There is some drawbacks to the design, because the fact that we introduce a function make it that ADL it is not available anymore in this namespace. Then any class that is defined in this namespace need to use other ways to customize. And for example, on the range.ts, the class tag should use this tricky way of defining swap as a friend function. For example, if we wanted to customize swap. And again, when we find a function like this one, this is taken when we are on the second phase of lookup. Okay? Before trying ADL, we try this one. Overloading resolution in C++ is very complex. Then I would say that, yes, this works, but we need to use different ways to customize. For the users, we customize using overloading the function on the namespace. For the standard, we will need to customize this way. It works. And if we want to customize an enumeration, we don't have yet maybe examples, but we cannot define a frame function nested in the enumeration. Then we need to move the enumeration to a hidden namespace and define the customization for this enumeration and introduce the enumeration on the standard namespace. This means that the user, we will not be able to find this type. We don't know on which namespace it is. It is on this hidden namespace. Then we will be unable to customize anything for these enumerations. And this, I believe that we don't have yet cases, but because we don't customize very often enumeration, but anyway. Then I would say we don't have yet the problem. I will use some, I will try to define the function that Andrzej Kasarski, I don't know how to pronounce it, apologize, has defined in his blog. But I will try to define it inside the standard, as if I wanted to add a new function. Then I define on std standard experimental, I add a namespace detail, I add my forwarding function in case the user defines the mem usage, oh, sorry. The mem usage function, what we want to do is to calculate the space used by an instance object. Okay, the space used by an object is the space used by itself and whatever it is referenced that it is owned by the object. Then, if the user defines a member users function, okay, he knows better. We will forward to this. If, but for trivial types that don't have pointers to anything, but the space use is just the size of. And then, once we have defined our default cases, we define the function object with the overload the operator call, and just move forward to this mem uses function using ADL. Okay, so far? I believe that this should work, but I have not tested. We don't need this trick of using a template to, I believe, I have not had the opportunity to check with a last version of the compiler. how do we customize, for example, what is the size used by a pointer that owns maybe this. Then we need to add on the detail namespace this overload for mem usage, and we will say is the size of V, and if there is something pointed by V, we will add the memory uses of the thing we point. Otherwise, we add O. Okay, that means that in order to define mem usage for a pointer, we need to have the mem usage for the pointy. This is what we have here, and this is an error. This still type of mem usage of. Okay, there are some typos on the slides. We are requiring that, but here we cannot use stdx mem usage because it is defined later on. That means that here we are using the overloads that are defined here or found by ADL, but not this one. What happens, this is, okay, we cannot use it. I will skip this one. No. I need to follow. Okay, we cannot use it. That means that when we customize in a recursive way, we cannot use the client interface. We use something else. And this, I believe that it is not good. We will see why. Now, for example, for those that were yesterday here, I want to customize it for any product type. Any product type, any struct, any CRA, any class that have customized the tuple-like access. And in this case, we will define it following one specific formula. We add the size of the variable, and we add the memory uses of the part, and we remove the size of each one of these parts. This is not important. It's the type of implementation. What is important here, again, is that we cannot use stdx mem usage. The overload is here, memory usage, and I need this helper in order to have all the indexes, in order to have this pack expansion or fold expression in this case. We are using here fold expression of C++17 in order to have this expanded adding. We are accumulating, okay? This works well for a product type as pair, no problem. However, if I take a pointer to a pair, this will not compile because I have this overload that use, mem usage, and the second overload for product types is later on. We are not using ADL at all. We are just using the templates that are defined on the same namespace, on the detailed namespace. And this overload will not be found when we are expanding here. Okay? That means that the order of the specialization on this detailed namespace matter. We could think of forward declaring the function, but I have not added here all the constraints. We need that each one of the elements of this product type define the mem usage function. And when you have a function like this one, I cannot forward declare it. I have just put it in order to show the order. But I cannot forward declare functions that use sphinae. I cannot. This doesn't work. We need to define the function at the same time. Then we cannot mix all these customizations. Pair of another product type will not work neither, because we are using here something, and we need to define the definition for product type is there. Then, when we have a concept that we need to call to the customization point recursively, this will not work. The function here, the name here, mem usage, it is only access the functions that are in this namespace or found by ADL. And this function is not found by ADL. Okay? Okay, another point. I will not take too much time in this one. Imagine that we want to serialize an object. And I want to be able to load an object from our archive. And I want to have this interface. I want to load an optional T from an archive. Okay? Here, my customization point will be optional T. Optional T don't appear as parameter of the overloaded function. Then I cannot use ADL for that. You see what overload will work only on this archive variable. Okay. Then what we can do is change the interface, at least the customization interface, and say I will, instead of requesting it as a template parameter of the load function, I will pass an optional that will be passed by reference. But this means that I will be able only to load things that are default constructible. Could be not a big constraint, but it is there. An alternative is to use some kind of tags that will help to use overloading, but we see that the customization point is just a little bit ugly, I would say. There are other cases where I will need to customize on parameters that are not are templated parameters, but are not arguments of the function. For example, a non-function that returns the non-value associated to a new label concept, or when we have a factory, I will like to be able to make an optional X in this way. Then, when the parameter is not deduced, overload don't work neither. I will. This proposal is an old proposal. Have a lot of good, very good goals, a lot of good things in it. I will not spend time. I suggest you read it. It is I don't know why it was rejected. or nothing from him, this proposal was retained. The idea here is just make it easy to use the interface correctly, make it hard to use it incorrectly. It is a source of, I believe that there are a lot of things interesting in this proposal. What I will insist that in this proposal, there is this subject of name reservation. When we have ADL as mechanism for customization points, we are reserving these names. When two libraries use the same name, there is a clash. And I consider that this we have as pseudo keywords is something that we should avoid. There are a lot of them, exactly what I have been said. Just a little remark, when we want to avoid ADL, we can qualify, we can use parentheses around the function we want to call. This is, I will say, the kind of code I don't want to see in my products, or defining a function object, a variable. Firstly, we will avoid ADL. Okay, threads. I want to be able to associate the customization points to a concept. I want that this customization is explicit to avoid unintended uses. And I would like to have a simple way to do that. An easy way for the user to do this kind of customization. Help a little bit about where ADL should not be applied. I want to be able also to refine, to extend concepts, customization points. And I believe that this is C++. We need to consider always that we need to be efficient, and we are not the right to add more code than needed. And in order to take in account the backward compatibility, we need to see a path to move to where we want to go and where we are in a backward compatible way, and maybe use depreciate, and so the design need to take in account this transformation. For that, I need some kind of explicit namespace to which I will associate. I will use this new feature to the concept of the customization point. I will define a thread class, a template class, a class template, sorry, associated to this concept. The function on this explicit namespace will forward to the thread. We will see the user will be able to specialize this thread. And we will respect the same thing as the current proposal of new customization points. Either we use it this way or this way, the behavior is the same, and we ensure that the customization of the user is always called. Threads. Do everyone know what a thread is? Threads. A thread is simply a class template that associates to a type something. Functions, types, constants, doesn't matter. We have a lot of threads in the standard, in the type threads. But threads can be used for any mapping we want to have. What I mean by an explicit namespace. An explicit namespace is something, it's a namespace that needs qualification. I don't want to use it. I want to be able to add things. It's an open thing. It is not a class or a struct that is closed for addition. It is open for addition, but I don't want to be able to use the things inside without qualification. I want to be explicit. Then, when I use it, I will need to use it in this way. Okay? And I want also to use it in this way, but when I use it in this way, I am, as it is an explicit namespace, I am changing the way we do overload, and this will inhibit ADL. And we will have as if we have something like that. That means that when you're using an explicit function of a function of an explicit namespace, it's as if we were defining a variable of the overload set of this function. We will see a little bit more. And we use begin. And as we have described already, when we have a variable, ADL is not available. Okay? Then an explicit namespace is something that helps us to be more explicit, and when we use something inside, we remove ADL. We don't want to call something else than this function. I will. What is behind this proposal overload set that it is for C++ 20? It is as if we have this begin, if we have this variable that is a lambda, okay, that is overloaded for any number of arguments, and if this works, okay, I just forward to this. This is the meaning of this line. We will have surely, and I expect this is very concise, useful in order to use high-order programming. We don't need to define the function object. It is the language that just will do it for us. The compiler will construct this object, this overload, that to name functions that are templates. Then, when two libraries define the same thing, the same name, begin for range or begin for book or I don't know what, if we try to use both, we will have a clash. And this will not compile, of course, because we have an ambiguity. We don't know which of them to use. Okay? Maybe we can refine if the overloads are different, do things different, but I believe that it is a good thing to, you want to use two symbols that are named in the same way, and we say if you inherit from two classes that provide the same overload, with multiple inheritance, you need to be explicit. You cannot let... Okay, then let's see how we can do it for begin-end. Then we define an explicit namespace range. We define a class thread. And I am using here something an enabler so that I can specialize the threads for concepts. This is a technique that it is used. We use maybe void T in the standard. This is how Bushana use it. And I believe it is a good thing. And then when we are forwarding just the threads, forwards to the threads when true. And in this case, what we do? Just delete the functions. Okay? By default, the functions are not there. Okay? It is more explicit than don't defining them. Because when we fall in this case, we will have the begin function has been deleted. Then we want to specialize the thread here, for example. We specialize, where am I? Okay, once I have the threads, I define the functions on the range, explicit namespace range, that will just forward. Okay, here we are forwarding to the function apply begin, and I have named it apply begin. I have not named it begin because we need a different name. And apply end. Then we are just forwarding to the threads class here. Threads, apply begin. And we call it if it is defined. Okay? If it is deleted, this will not work. Here, for end. And if I define a concept, I want to have a way to check it. With C++ concepts in C++20, maybe we will have another way to do that. In my prototypes, I am using these kind of things to say it's a range if these functions are defined. Now I want to specialize for types that have members begin and end. And we just forward to the x begin, x end. These threads, it is just something that will check that this and this is well defined. Now I want to specialize for ADL so that I am backward compatible with the current way we do that on the standard. And I check if I can find this begin end by ADL. I have not the details on the presentation. And I just forward. And when there are sometimes that we can have both. We can have the member function and the overloaded function. And we have a conflict, and we need to say what it is, what we choose before. Then we use ADL only when there is no a member function. This is how the standard defines it. Okay, then we have a path to define things on the standard that allow the people to continue to work because begin and end are found by ADL. I wanted to be able to refine. Then, for example, if I have an explicit namespace for the functor concept, doesn't matter what this means. I want to be able to use all the things of this functor concept when I define another concept, applicative, when I define another concept, monad. This is some kind of inheritance of refinement. Let's see how we can apply this to our function mem usage. I need a name for the concept, and I apologize, I have not found a good name. Mem uses able. Sorry. But we need a name associated to a concept, okay? Just we delete. When it is a trivial, we return type size of. For example, for optional, here is the. And one thing important is that this could be found in another file, okay? The specialization goes outside. It is not on the same file of the function. I forgot to do this remark. Then for optional, just the same thing. If I have something, I need to add this memory usage of this thing without it is not very important. What is important is that we are able to use the user interface. For a product type, we will, in this case, we will specialize when the type is a product type. And we write this in this way. And we can have this on this file. Okay? We define the specialization of mem usage for product types and some files associated to product types. Sorry. And we have that we can have conflicts. We can have that when we specialize for two concepts, we can have types that model the two concepts, and we have to manage with this. And one way to manage with this, as I said before, is to give a priority. What we can do also is to prepare our customization so that we define in product type a way to make it as mem usable. So that when someone wants to customize, could reuse this customization. And we will define by default when it is a product type, we use this default customization for product types. But we have here a name that can be reused when we will have a conflict. And for a given class that is, for example, trivial and product type, we'll say, I want to be specific, and the customization for this class is just reuse this one. See this class as a product type. I want to use this customization. We can use tags so that instead of having a different name, as here, as mem usage, we can use some tags so that we name it thread the product type tag. I am not sure it is something that helps the understanding. We have one problem with overloading. When we have overload, the overload works also for the derived types. When we use threads, class specialization, we don't have anymore this issue. But as I said, maybe we wanted to customize for the class, and the class is the inheriting from this class. And we could do that with threads. Simply, if for the derived classes, you can define a thread that for this thing, use the threads of X. If we wanted to add it, we can either use the threads for a class X or use some predicate. It is up to us to define a specific customization of a more generic one. Okay, let's see a comparison between them. I believe that this is a major thing against this approach. All the customization associated concept should be defined on the same file in a given order. We cannot define this function in S-friendly. That means that we will have definition even if the types don't define this function. We don't want that. This is the same thing. Recursive types don't work in this case. But people, I would say, used to understand, some people understand already how we overload using ADL. Adding an additional way, it is always a drawback because we need to tell them how to do it now. Having two ways to do the same thing is not a good thing. But if we want to move to a newer, or I would say better way, we need to have both during a time. What cannot be used for enums, as we have already seen? We can have some violation of the one definition rule with threads. If we have two specializations of on two different files. I believe that this is a global problem of specialization, and the approach of Eric don't have this problem because it forbids to specialize for concepts. And then we can see it as a positive point. We don't allow others users to specialize for concepts. The standard has this philosophy that things that are different in the standard, we don't want the user to change too much because we want we expect to have a well-defined behavior. Then I believe that forbidding maybe in the standard to have a specialization for concept, it is maybe a good compromise. Then if we consider that we want the user to be able to do anything, then this approach has a negative point, and the threads work for all. And the last point we have is that we can customize in an unexpected way, and in the case of threads, we can be explicit, either with are customizing a type or a predicate. Okay. I will finish with 3 open points that I have not an answer yet. It is about when I have a concept, I want a thread for each function or a thread for all the functions associated to the concept. The second open point is, should the thread be specialized for a specific type or for something that we could name type class? We will see. And the third one is, how do we manage with operators? Let's see. Then Boost HANA started to defining threads for the whole concept. He has moved just before being introduced in Boost to one thread by concept, by function. And I know that the author, Luis of Boost HANA, has done that because he has found some problems. I have requested him, and he has forgotten why. But then I need to have more experience on using this mechanism, so maybe reproduce the problem he found one day. Then instead of defining a single thread, we will define one thread for each function. This is the change. We can do like that or like that. We don't know yet which is the one that has more advantage and less liabilities. HANA uses also some kind of category of the type, some kind of to why class of types these types belongs. Then instead of using the threads directly on the type, it uses the threads on the tag of this class, of the type class of this class. This, I will say this works, but once you have a specialized, given a category of your type, you cannot change it. And all the specializations will need to use this category, this tag of. This could help maybe to reduce the code. I believe that is something that need to be considered. And without this kind of tag, just what we can do is, okay, I will specialize optional R for this thread using the new label tag. I am retrieving, saying, okay, optional R is a new label in this context. I can reuse some threads. Okay. Then the tag is something that it is useful. And here, for example, is the slide that I should not show before. We can do it like that. We can define the threads and reuse with the prototype tag. It's the same. The way we retrieve this kind of, we associate a category to a type, but on a specific context. The last thing, operators. we wanted to be explicit. We have added an explicit namespace, and we qualify always each time that we are using a customization point. But we have that we like to use in fixed syntax for some concepts that could be much or less acknowledged by a community. Then this is how it could look like the chaining of a function chain or bind, and people don't like to match this syntax. People prefer maybe to use this syntax. In any case, for arithmetic operation or logical operation, anyone admit that we need to use plus or, and we don't want this kind of things. Then the problem is that we cannot found this kind of things where we use, we cannot overload the operator. We can overload it, but we cannot find it associated to a concept. Okay? We can overload it for a specific class, but not for a concept. Then there will be maybe a uniform function called syntax in the next standard, C++20, and we could think that maybe this could be possible. I believe that it could not be possible because we have required that the customization point is qualified by the concept. Then I believe that this will not work. And there are libraries as Fit and HANA that use some complex overloading approach to make this look like that. This is something that is good for playing, but I don't believe that we want to have this on our product. Here, we are overloading these functions in a deep way. We have one operator, two operators that are overloaded. It is tricky. Then it looked like, well, but if we have an error, it is something that it is quite complex to find out. Okay, then we can define these operators on a specific nested operators namespace. Then we define on this namespace, these operators are not available. Otherwise, if we request them explicitly, then this is the way we could have operators associated to a concept, and we request them explicitly. There are other techniques to be able to have to associate a class to a namespace on which we define operators, but it uses inheritance, and as not all the classes could use inheritance, it is not something generic, and if we want to have a generic code, this is the way we could do that. Okay, conclusion. I will repeat what I have started to say. We have today some problems on the customization way of the standard. We don't have found them because we have not tried to customize concepts. And the single concepts we have tried are not recursive. We have defined swap for types that are move constructible and assignable, but we don't call to swap again. It is the problem when we call again that we need something else. The use type, even if it is a minor thing, I believe that we need to address it. And we need, I believe, an approach that it is used on the standard and that the users can use also. And when we teach how the standard works, it will be great if the people can use the same mechanism. If the standard uses a mechanism that we cannot use on our side when we define our frameworks, I believe that it's a teachability problem. Just to finish, say that I believe that being explicit, it's a good thing, and splitting the interface of the client, of the customization, is always good in the sense that we are addressing different problems. The user interface is something that should be easy to use, and the customization easy to customize, but we are on different doors of our class. I believe that the current approach solves some of the problems, but I am not yet happy on. I find that it is there are too much noise yet, and I would like to have a signal to ratio to noise ratio that is better than that. I have not found yet how I am happy with this. I can do a lot of things with this design, but maybe we will need some additional changes on the standard in order to make this to convey the information we want with less noise. As yesterday on the slide you find the reference that the presentation contains, reference to libraries and blog of presentation that are related, and that if you are interested are good things to watch or read.
Thank you very much. Once again, big thank you to Vincente.